Okay, I see attendees starting to pop in here. Thank you so much for your patience. I know we're starting a few minutes late here. We were about to click broadcast when our internet went down. So that's been fixed. And it in those 11 minutes, it started full on snowing outside. So welcome to April. That's not a joke. It's snowing outside. I'm James. This is Diego.
I'm Diego. How you doing?
And today we're going to be talking about simple machines. And I am so excited to hear what you have to say about this, Diego.
All right. Well, let's get started.
Let's.
So this is one of our courses at Delvian. It's called Simple Machines. This course is jam-packed with stuff. There's just so much to learn about simple machines. But let's start with the purpose. Purpose is good.
What's a purpose for a simple machine, Diego?
There's a lot of purposes. So before we get into that, I'm going to start off with the high-end stuff.
Yes.
This is one of our robots that was built by our students. So our students competed. There's a competition called First Robotics. Great competition, by the way. A lot of schools do it. But the student's job is to make a specific robot that will do a task. Like it will pick up so many blocks in a certain amount of time. And so they compete with other schools. So it's kind of like a varsity sport, but it's robotics. And there is so much need for robotics, right? You see it in industry, you see it in the space program. Robotics is just all over. Now, what does robotics and simple machines have to do? So first of all, let's start with the definition of a simple machine. A simple machine is anything that helps you gain an advantage, some kind of mechanical advantage. Like, for instance, let's just start off with, an inclined plane. Okay, so you have a book, or you have, yeah, we could use that inclined plane. But if you have any kind of ramp, anything that gets you to exert less force over a distance is an inclined plane, right? So we have a rolling pin.
That didn't roll very well.
Didn't roll too well. But like if you have to, if the pen was really heavy, right? We'll pretend this is a big tank of something, and we have to move this up to a certain height. We have that inclined plane, and that inclined plane will allow us to exert less force on that. So that inclined plane is a simple machine. With this robot, we have tons of simple machines going on because these simple machines all add up to a big complicated machine. Okay, so when you think of why study simple machines, robotics, right? Doing more and more fun, complicated things. So look at this thing.
I'm looking.
Yeah, I'm not going to get into all the simple machines on there yet because we need to learn about them first, but this is where you're going in the subject. So why study a course like simple machines? So you can get here. So you can get to building cars, engineering, making more complicated machines.
Are we going to build a robot today?
Not today, not today.
Are we going to learn some of the stuff that we would need if we wanted to build a robot?
That's right.
All right.
So we started off with the inclined plane as one of our simple machines. Here we have a board. Let's pull the board out. And if you're doing this course at home, the book can be ordered. There's a check sheet, so it's a self-study guide. But you end up building a lot of things. For instance, we take this inclined plane, this in here, this inclined plane, and then we measure with we measure with scales to figure out how much weight it takes to pull up this block, right? So one of the goals would be to get this block to elevate maybe 2 inches. So we're trying to get this block 2 inches. And if we attached a thin piece of string, this block, it might not hold that block. So we're pulling up the block and then the string snaps. But we can still get it to the 2 inches with less force by pulling it up the inclined plane. So that gives us what's called a mechanical advantage. It makes it so that way we can exert less force and do the same amount of work over a longer distance. So how is that helpful, and how does that get you to robotics? Great question. Oh, and also don't forget to ask questions. We have a Q&A on our Zoom, so if you have questions, go ahead and shoot. James will help filter them, and we'll get some of the best questions out there.
Yep.
Here's another, so inclined plane. This is a file. Now, it doesn't look like an inclined plane, but if you were to zoom in, which our camera really can't, but if you were to zoom in really close, you'll just see there's hundreds and thousands of little inclined plane surfaces on this file. And what it does is, if you have to sharpen, or if you have to file something down, you start working the tool like this, and what it's doing is it's taking little chops at it on little tiny inclined planes there. And so what it's doing is it's taking pieces of that metal. So you could take a file like this, and you can file something, and if you spent enough time on it, you can actually, with a file, you can go through a solid piece of metal using the inclined plane.
And patience.
And patience, yeah. And patience, yeah. Yeah, yep. The next one, let's talk about the screw. So,
and I'd like to ask a question that we'll take a moment to define this. What is an inclined plane? What does that mean? Like, what do those words mean? And then we put them together to mean this.
Sure, inclined plane is anything, any like a ramp. A ramp would be an example of an inclined plane. Anything that helps elevate a mass from a lower level to a higher level.
Okay.
Yeah. So that would be an inclined plane. And then, so back to the screw, right? So you can take a piece of wood. You can do this at home. It's fun to do. If you haven't done it before, you just take a screwdriver, and we can put it in the end of the wood and drive it in. And this is one of the simple machines called a screw. And you've seen these before, but what are some of the applications of a screw? There's tons of them. There's tons of applications, and I don't know if you can see that too good, but
kind of.
Yeah. And this actually has inclined planes around a center post, right? That's all a screw is, or it's these inclined planes around a post. So one example of where we can use that would be, I had the clamp. Okay, that's fine. Well, here's one. There's a screw here. This is a pipe wrench, and this is used as you turn this knob. The teeth of the pipe wrench clamp down on something, so you can use it to clamp down on something and get a good bite on it, and then you can turn whatever it is you have to turn. So that's just one example of a screw. You have any examples?
You're way ahead of me on this.
Okay. Okay. Yeah. So there's a lot. Another example would just be drilling. So drilling, if you look at the end of a drill, it has a bunch of screw parts. When I pull the robot back up, the plan is at the end of our time here. So tell me when we have about 10 minutes left.
Okay.
We'll pull up the robot, and we'll point out some simple machines on the robot.
Great. Chris had a good question here. Is the screw or the screwdriver the simple machine? It's a great question. I think the answer is both.
Yeah.
Working together.
Right. The screwdriver is not really considered a simple machine. Now that I think about it, you do have the wedge, which is another simple machine, and the wedge fits inside the slot. So that little aspect of it is a bit of a simple machine.
Yeah. Anything that helps make a task simpler,
Yeah. Anything that gives you some kind of advantage. There's a lot of different types of devices. Inside a drill, you'll have a bunch of simple machines. If we were to take this apart, you would see parts that turn around and add more force. And so what they can do by adjusting different mechanisms on the drill, it gives you different ratios on those parts that screw and use the inclined plane to keep things driving. So it allows some of your electrical force to be converted into some more mechanical forces. Yeah. Like you can't just have a battery. You have to have and you can't just have a battery and motor. There's gears in there that are themselves made up of simple machines to make things more complicated.
It's amazing how much you can do, how many different millions of things you can do with, if you take something that's flat and you tilt it a bit and use that to get something done.
Yeah, for sure. Investing in learning simple machines is really fundamental. One of our teachers, Joe Sessions, he was where did he graduate from? Georgia Tech? Georgia Tech, and everything, working alongside with him when he was developing our RC track at the school, everything was to remote control cars. Everything was simple machines. He would get up on the board and he could calculate things, and then he'd have a great robot. So I have a new appreciation for simple machines. Okay, so there's the screw. The other one is the lever. Have you ever done this? Have you ever grabbed a pair of pliers? Be careful if you try this, and just kind of squeeze your thumb to see how much pressure you can generate. If you squeeze really hard with this, you can generate a lot of pressure. That's why people use pliers, right? People use pliers so they can grab things, right? So if I was making a knife and I needed to get it hot or something, I can grab this and it can hold on to this really tight. Like I could have a match with James over here, and I could grab this and hold this, and he's not going to get away from.
I got nothing here.
Yeah, but if I was to hold that with just my pair of fingers, he'd probably give me a splinter. Yeah. So what happens is we're using the lever, right? These are two levers, and they're around a certain pivot point, and the further out we are, the less effort it takes. So if I'm just squeezing here, I can't generate as much force compared to if I squeeze out here. Then you can really generate a lot of force with that. And if you take a pair of pliers and just kind of be careful when you're doing that, if you do this at home, but you can feel the pressure, you can perceive the pressure on your finger out here compared to out here. And this is a simple machine giving you mechanical advantage. It's multiplying your effort into some more effort.
There you go.
It's an effort multiplier. Yeah,
I like that.
Yeah. So those are levers. Another example would be of a lever would be if you're prying something. Like say you have something that's stuck on the ground, and you come in with a lever, and you're picking something up. You're trying to pry it off, right? People like a pry bar. People will use screwdrivers, a big bar. If you're trying to move a big boulder, you can take a giant long lever, and then you get underneath it. So the longer your lever is, the more mechanical advantage you'll have. Well, those are levers, and then you'll see those in robotics. One fun topic, because I was studying this, getting ready for examples today to talk to people about martial arts.
Yeah,
martial arts. So levers, when you're engaged in combat, right? You can use people's hands as levers, and there's moves there. So if anybody out there studied martial arts, you're studying basically simple machines.
There you go. Yeah. That's awesome.
I'm going to show James real quick levers and arm wrestling. So James, put your arm up. Now, if I'm struggling with James here and we're at the same level, it's basically arm against arm. But if I come up higher, right? If I had a longer arm, right? So people with longer arms already have like a unfair advantage, right?
I'm about to lose, aren't I?
Yeah. So it's interesting how even arm wrestling, things like this come into play with simple machines. The body, believe it or not, is made up of simple machines. You can figure out things. When people who make artificial limbs, they're kind of like roboticists. They have to they have to figure out mechanical advantage for different levers and all these different simple machines.
Awesome.
The other one is the wheel and axle. This is a great one. So we have a wheel, we have an axle. Anything that a wheel can rotate on is considered an axle. And then of course we have a wheel that just spins. You could put a couple of these together. You can make cars at home. But this would be your wheel and axle. So here we have a wheel and axle on an inclined plane. So in this book, you go through some of the calculations on how to figure out force, how to figure out what mechanical advantages. So like we have this inclined plane. If we pick it up 5 inches instead of our 2 inches, how does that affect, right? What kind of different forces are acting on if you have to get a big load up that inclined plane? So tons of applications. The other one is the pulley and rope elevator. So a pulley is basically a wheel with a rope around it. And I didn't bring a rope in today. Oh, here's a piece of string.
There we go.
Yeah. And really, anytime you, let's see if you can see this too well here. Oh, yeah, it looks pretty good. If you throw a rope over a tree branch, and then James, if you'll tie that on there. So if you
realize I was gonna have to tie knots in the webinar today. This is
yeah. So if you throw a rope over a tree branch, this is your tree branch, and
just do that lightly there.
And you throw.
That's not gonna stay.
That's fine. And you throw a rope over a tree branch, what happens is you're redirecting force. So as we pull on this, as we pull down, we're able to pick this up, right? So that simple redirecting of force gives you a mechanical advantage, because instead of pulling up the load directly, you can, if a bunch of kids were in here and they're trying to pick up a tire, they could be pulling on this, and they're using a gravity assist, right? They just, all they have to do is grab onto the rope, and the weight of gravity picks them up and helps pick up the tire, right? So we take the forces of nature and we redirect them, and we make fun things like tire swings and all kinds of different things.
Yeah.
Yeah. So that's a little bit about the pulley and rope. James, if you will hold this right here. Perfect. So let's see, I haven't tried this, but what the heck. So now with like these, if you could imagine there's little wheels on them to make it go smoother. I can do things with these 2 pivot points, like I can bring the rope like this. And if we were to measure this on a scale, it's actually even easier to pick up the rope. We end up getting a mechanical advantage because we have a little pulley system going there. We're able to pick up that rope with a lot less effort. Now we have to move the rope further, but we're able to get that mechanical advantage. Mm-hmm. So that is a pulley rope. Where do you see pulleys and ropes? Shoot, if you have any ideas.
I mean, first thing that comes to mind is an elevator.
Elevator.
Like in there's all the ropes and cables, and you see a bunch of wheels in there. I imagine that's being used to help redirect that force, make it easier to raise and lower that elevator.
That's right. That's right. Yeah. So elevators are great example of that. Another example is the streetcars in San Francisco. I don't know if they're still on a pulley system, but back in the day they were on a pulley system. They had a bunch of pulleys and cables under the ground, and they were able to, they have a system where they're able to move these things around and pull big carts of people.
Yeah, Shrishti says examples of pulleys in a well. Ariana says barns to load bales, like bales of hay.
That's
Mina
right.
says boats in order to raise the sail.
Oh yeah. Boats. Gosh, boats are amazing. If you ever get a chance, maybe some of you know how to sail, learn pulleys and ropes. I mean, it's amazing that these simple machines, you're able to take a vessel, and if you know how to use the machines right in your body, and you can sail all across the world.
There we go.
Just using pulleys and ropes. And fantastic. Who was that from?
Let's say that was from Mina.
Mina.
Charlotte says flagpoles. Yep.
Flagpoles.
Milo
great.
says in a catapult.
Yeah, awesome.
So many useful
Yes.
ways.
Awesome. So pulley ropes. The other one is the wedge. So if we had a block of wood, so here's our block of wood, and when you're separating wood, I didn't bring it into our classroom today, but if we were outside and we had to chop wood, when I was growing up, I had to chop a lot of wood. Lived in southern Colorado, so that was just life. But you take your wedge, so in this case this is a knife, but a wedge is anything it's basically two inclined planes. So in a way it's actually part of these other simple machines inclined planes, but a wedge is two inclined planes like that. So in this case it'd be our knife. And if I were to take a hammer and hit on this, boom, 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 I could drive this wedge in between our block of wood. Maybe if I turn it on this end, right? And I could end up splitting the wood, right? So what you're doing is you're taking that wedge and cleaving it. You're separating two things together.
Like if you had some really hard butter just out of the fridge, or like a block of cheese, and you've got your knife on there, you could take another knife, a spoon. If you're my son, you might just grab a hammer and like, you really want to eat that cheese.
Yeah. People have wood splitters. All it is a wedge. So you put your block of wood in there. There's a wedge in there, and with hydraulics, it just drives it in there. The wood splits.
Yeah. Isaiah asks, is it like an axe?
An axe is definitely a wedge. Perfect. Yeah,
exactly.
That's all it is. Some smart person back in the day when the first axe was built, they went, okay, we have this wedge. We add it to the end of a device, right? And then we go and hit wood, and all of a sudden we're chopping wood. So yes, an axe is a wedge.
Chris says a hatchet. Wow, a lot of great examples coming in. Ellie says a wedge. An example of a wedge is a door stopper and a
door
knife.
stopper. Yeah.
Yep.
Perfect.
Awesome.
Yeah. It's really important to start looking around the environment. The more you learn about simple machines, the more you can just spot them. You just like simple machines. Like as we look in our broadcasting room today, we have wedges and screws on our boom mics, on just everything. They're just all over the place, and they're all over your body. Simple machines are just everywhere. So real quick, let's do a rundown of all the simple machines.
Okay.
We have the inclined plane. Real quick, I want to see who can name all the simple machines that we listed.
Oh boy, okay. Q&A box is going to get busy here.
Yeah, let's see. List them all. We're going to wait just a second. What are all the simple machines? All the simple machines that we went. So there's 6 of them. Okay, so I'm just looking for the 6 basic ones. So do we got them? We coming in?
All right, we're gonna give people a minute to write into the Q&A box here.
Okay, cool.
Yep.
All right, good. So I'll just go ahead and give them. So we have the inclined plane.
Write them here too if you want.
Cool. Will you write them for me?
Oh, first I had to tie knots, and now it's a handwriting test. All right, go ahead.
Inclined plane. Good. And screw. Good. Lever. All right, good. They're coming in.
I apologize if my handwriting is bad. And let me see if I can get this. There we go. There we go. That's much better.
All right, good. So we have our lever, our wheel and axle.
Let's make that bigger.
Pulley and rope.
Okay.
And the wedge. So, question, interesting question. A nail, what is a nail? What would a nail be? What would a
Well, I'm
nail
going to
be?
guess it's a sharp piece of metal.
Yeah, yeah. You're totally right. A nail is, so we take a nail and we pound it into a block of wood. What kind of simple machine we're using? If you guessed wedge, you're totally right.
We have a ton of people writing in with all the answers here. I can't even read them all. Everyone who wrote in, well done. Thank you.
Good.
You guys got that quicker than I do.
All right. So let's take a look at our robot.
Yes.
And let's see what kind of machines there are. Oh, another awesome simple machine. The skateboard. The skateboard. We have wheel and axle, right? We have wheel and axle, and as a skateboarder uses a skateboard, they are using a lever. You actually have a lever there. Skateboards have, not all of them, but most of them have a little bit of a lever type of action. So your back foot, you can put a little force down like that and shift your weight, and you're able to have that like lever action, right? And the person does all kinds of tricks. All you're doing is you're manipulating all these little simple machines of your body and the board. All right. So here we go. This was Delvian's first robotics team's robot. Gosh, this the amount of work that went into this. Where do we start?
Well,
you see any simple machines here?
Let's say, we'll probably just go down this list and find just about everything. Incline plane. I mean, there's screws all over the place on here. So anytime there's a screw, incline planes are involved.
That's right.
There's probably hundreds of screws on here.
Yeah.
Right?
So we have all the screws.
Yeah.
Right. The screws there, and then the incline plane. So we designed a hook on this. So this hook has a specific shape that you can see, and it's in the shape of an inclined plane. Why would we need that? Well, when this thing had to go up and hook on certain objects, it had to, that shape, if we would have just had a sharp, I would say blunt end on it, it wouldn't grasp things as good. It couldn't go around and pick things up. That inclined plane helped do that. So that's a specific example. Like James said, there's so many screws on this. For instance, here, this part, I don't know if you can see this electric motor. If we would have used nails on that, what do you think would have happened after weeks of using the robot?
Nails probably would have just fallen right out.
Yeah, they would have fallen out. But with the screw, it was able to put a lot of force on that and keep that motor bolted onto the frame, the chassis of this. And then lever. Okay, so where would you have the levers? Yeah,
Got a lever right there.
there we go. Yeah, we have a lever. We have this pivot point here, right? So we have the wheel and axle. We're right into wheel and axle. We have the motors. We have screws. There's so many different parts to this. The way this robot worked is it would go around and pick up these blocks that had little hooks on them, and then it would throw them into another container.
Great. Wheel and axle, plenty of those.
Yeah.
Along with that, and here.
Yeah, these tires are pretty neat. So not only do they go forward and backward, but they go side to side. So they have kind of a cool design. I don't know if you can see that, but this thing can pivot. This thing can turn on a dime, is what they say. But it makes it so they can turn really easy. Pulley and rope. Do we have any pulley and ropes on this?
Let's see. I mean, I'm kind of looking around. I'm not seeing any ropes. Oh,
Yeah.
Oh, there we go.
Yeah. So this thing would.
I gotta come and do this with you
Yeah,
next year.
totally. This, let me take these off. Our numbers.
There we go.
Yeah. So you have your pulley and ropes there. Your wedge. So that's there. All the screws. All these types of things. So why study simple machines? Robotics. There's a program that NASA has called the Artemis program, and this program is to get a space station that's going to be around the moon. Now, a lot of that, they can't send up humans. It's too pricey. It costs a lot. So a lot of these things are going to be set up by robots before astronauts even get there. The Artemis program is amazing. Some of you guys, the program's being launched. The goal is to have a man and woman on the moon by 2024. I was at NASA in February at Johnson Space Center, and the big thing that they need, the future workforce, is going to be robotics. And how do you learn robotics? Simple machines. So this course, anybody out there who has time on their hands, which is a lot of people, I highly recommend parents come and get this course and just have their students learn it right away, because you start building things at home, all the stuff in there. I'll go over some of these chapters.
I'm going to leave our friend on screen here.
Yeah.
The third co-host.
Yeah. So some of these chapters, this is all stuff that applies to us getting to space, NASA getting to space, mankind getting to space and going to Mars and all these things. Of course, this book starts off with 6 simple machines, which we just went over. Matter, like what is matter, right? What is matter, and what is all the stuff that's made of and how to measure it. Really, really interesting things like that. Inertia is a great thing about simple machines. We got into some problems with this robot because this robot would get going too fast and we couldn't stop it at the exact right time. And so that's what inertia is. Inertia is the tendency of an object to continue in motion, or the tendency of an object to stay at rest, right? So when something's not moving, it will not move. And inertia, how that relates to robotics and setting up things, it's a fascinating study, really fun to study. Newton's laws of motion. You guys have heard these?
Yeah.
James, how important are Newton's laws of motion?
Well, I probably use them every second of every day without even realizing it. I think everyone did throughout history until Newton was like, all right, what's actually going on here? Can we actually put a name, put exact words to what's happening here?
Yes, perfect. Yeah, totally. It's all around us. Newton's laws, the class example, he's sitting under a tree and an apple hits him on his head. And he starts thinking about the whole, about the entire world around us, right? What is happening? Being able to redirect forces gives us a command over the physical world. And it's awesome. You're studying how to change the physical world. So that way, when we have ideas like, oh, I want to build this robot and it should do this and that, you're able to change the forces in nature and make them do something. That's why I study simple.
That's awesome.
Machines. Yeah.
And this course and a bunch of others are available on heronbooks.com. I don't know if we're going to be getting further into this later this week, but if you're interested in this and want to continue studying what we've started talking about today, you can go to heronbooks.com, find this course, Simple Machines, and it'll walk you through everything that we just went over and a lot more. Looks like we're running a little bit out of time here right now. So thank you so much for tuning in today. Thank you for your patience at the beginning as we had our delays in getting started. And I hope to see you guys later today and later this week as we continue our webinars.